reveals how Earth's orbit triggers ice ages, and there's one in the next 11,000 years. Earth's history is a roller coaster of climate fluctuations, of relative warmth giving way to frozen periods of glaciation, before rising up again to the more temperate climates, the climes we experience today. What triggers these periods of glaciation or ice ages is difficult to pin down, though for some time researchers have strongly suspected quirks of Earth's orbit around the Sun are involved. New research has demonstrated the precise relationship between past ice ages and each Earth wobble and tilt and angle of the planet's path, unlocking a new tool for predicting the future fluctuations of our global climate. The link between slight changes in axial tilt and orbital geometry and the waxing and waning of continental ice sheets represents one of the oldest mysteries in the climate science. Earth scientist Stephen Barker of Cardiff University in the UK explained, "As such, it represents a fundamental gap in our understanding of the climate system. Increasing our awareness of how Earth's dynamic climate system operates is crucial if we hope to be able to predict how climate changes in the future. Earth's orbit around the Sun is not perfectly symmetrical. It has a somewhat oval shape, referring to an orbital eccentricity, with the Sun off-center in the oval, which means the Earth's distance from the Sun changes throughout the year, and the position of that oval in space shifts a little with each orbit, and we call that orbital precession. Finally, the tilt of Earth's rotational axis, a property known as obliquity, changes as it orbits the Sun. It's been known for some time that these different properties of our planet's relationship with the Sun result in cycles of warmer and cooler climates, with periodic changes in different aspects of Earth's orbit affecting the seasonal and geographical distribution of sunlight, collectively known as Milankovitch cycles. These period changes occur roughly every 20,000, 40,000, and 100,000 and 400,000 years, but teasing out which aspects of Earth's orbit are involved in fluctuations in climate is not an easy task. Earth's climate is an interconnected system of complex processes, all acting together to produce the changes we observe, Barker said. Modeling these changes over the timescales reveal relevant to glacial cycles require lots of processing power, in addition to the processes themselves being difficult to quantify and model independently. For example, there are two very closely timed cycles, precession at 21,000 years and the second harmonic of obliquity at 20,500 years. No one has been able to establish a clear link between either of these cycles and the end of an ice age. In addition, for the last 800,000 years, ice ages have ended every 100,000 years, and scientists have been unable to find the cause of this cycle. Barker and his colleagues started by looking at changes in oxygen isotope ratios and the deep sea over the last 800,000 years, preserved in the fossilized exoskeletons of tiny marine organisms called foraminifera. These changes can be used to map changes in the volume of continental ice or ice sheets, a key metric in studying Earth's past glaciation. With this information, the researchers created a detailed graph of glaciation cycles, against which they compared two idiosyncrasies of Earth's orbit, its precession and obliquity. And an amazing pattern emerged. The critical stages of the transitions between glacial and interglacial periods matched up with a particular relationship between precession and obliquity. Deglaciation, the end of an ice age, seems intimately linked to a relationship between precession and obliquity, but it's obliquity alone that is responsible for the onset of the ice age. And this, the researchers say, explains the 100,000-year cycle, and it was all right there, hidden in plain sight. I was really excited when I saw the relationship between orbital phasing and the shape of the climate curve across these well-known transitions, Barker said. The curves we are looking at have been around for decades and have been looked at thousands of times, including by myself, and yet the relationship we found, which is easy to see when pointed out, remained but all hidden before now. Previous studies, he said, have argued that the timing of ice age onsets is more random. His team's work shows that it's deterministic, meaning we now have a tool that lets us predict when ice ages are going to happen in the future. And the Earth's obliquity is currently in the process of declining towards a minimum, which it will reach in 11,000 years or so. According to the team's calculations, the next ice age will kick off before then. This is vitally important information to understand the long-term future effects of current human activity, Barker said. According to the latest IPCC reports, humans have already started to alter the course of climate away from its natural trajectory by the emission of greenhouse gases, he explains. This means that the decision we make now will have consequences to the far future. At present, projected future climate change is gauged relative to modern or pre-industrial conditions. But we believe that to fully appreciate the true magnitude of future changes, these need to be compared with what might have happened in a hypothetical future, free from the influence of mankind. Therefore, we hope to create better predictions of future natural climate variability in order to quantify possible human influence into the coming millennia. The team's research was published in Science magazine. This is on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.